So in this lecture, we're going to discuss fluid power variables, specifically pressure and flow rate, and use them to calculate power. We're also going to talk about the difference between a through and an across variable and how that relates here. So first of all, pressure. Pressure is simply the force per unit area. And one thing I want to stress here is that unlike a solid where you can have tensile force or tensile stress, a fluid can only be in compression. It cannot handle a tensile stress. And so these pressures we're talking about are always a compressive pressure in the fluid itself. Now, our pressure is what we refer to as an across variable. And the reason for that is that it's always measured with respect to something else. So what do we measure with respect to? Well, often we measure with respect to atmospheric pressure, in which case we refer to it as gauge pressure. Sometimes we measure it with respect to vacuum, in which case we call it absolute pressure. Sometimes we'll talk about the pressure drop across the valve. And in that case, it'll just be a delta P, or a pressure differential from the upstream side to the downstream side, and that would be the pressure difference. But again, always measuring with respect to something else, and therefore talking about it as an across variable. So one thing you're going to find in this class is that units can be quite challenging in fluid power. And the reason for that is that we have to deal with both SI and US customary units. And you might say, you might be in another part of the world where you're not dealing with US units on a regular basis, but in fluid power you have to, because so many manufacturers are in the US, so many OEMs are in the US, and you have to jump back and forth between unit systems. So we're going to talk about both unit systems in this class, but one thing I'm going to stress is that I recommend doing your calculations in the SI system, and we'll talk about why in just a moment. So the SI unit of pressure is pascals. So a pascal is actually a very small unit, and so when we're often using this for fluid power, we refer to this as kilopascals or megapascals. Now, another common non-SI unit is a bar, and 1 bar is simply equal to 100 kilopascals. Now, the reason this unit is nice is because 101.3 kilopascals is atmospheric pressure, so a bar is very close to atmospheric pressure. So if you talk about 200 bars of pressure, you're at approximately 200 times atmosphere, so it makes it a little bit easier to relate that pressure. Now, in the US customary system, we refer to it in pounds per square inch, or PSI. And this is uniformly used. Sometimes in large water systems you'll have pounds per square foot, but PSI is the most common for high pressure fluid power systems. Now, our other major variable that we're dealing with is flow rate. And we're going to need to talk about both volumetric flow rate and mass flow rate. And flow rate is simply the volume or mass per unit time. And we refer to this as a through variable, or the flow across some imaginary plane. So if you can imagine, I've got this water spigot here, and let me draw a plane right here. Well, I can look at either the mass that has flowed across that plane or the volume that's flowed across that plane per unit time, per second, per minute, whatever unit we're looking at. So one thing we have to be careful of here is whether or not we're talking about a compressible fluid or an incompressible fluid. So for hydraulic fluids that we normally think about as incompressible, meaning the density stays constant, we can either use mass flow or volumetric flow. Volume flow is easier to measure, so we normally report it in that way. And so the units of volumetric flow rate in the SI system are cubic meters per second. Cubic meter per second is an enormous volume, and so normally we have to reduce this to smaller units that we can deal with, and this is typically used in liters per minute, is a more common measurement, but again, non-SI. Now in the US system, a gallon per minute is a very common unit of measure, but though you sometimes also see cubic inches per second, but again, not used as often as having to convert from cubic meters per second in the SI system. Now, pneumatic applications where we have gas as our working fluid, there we have to measure the mass flow rate because the fluid is compressible. The density is changing, so we can't just rely on the volumetric flow rate. So when we're dealing mass flow rate, our units in the SI system are kilograms per second, and in the US system are pounds mass per second. So again, be careful whether or not this is pounds mass or pounds force. In this case, it's a mass flow rate, so pounds mass per second. So how do we measure pressure and flow? Some of the most common devices for measuring pressure is just a pressure gauge. It looks like this, where we've got an input port right here. This is a pipe thread in this case. And then we've got a dial that swings both through a pressure in bar and a pressure in PSI. And we can just use this to quickly glance at the system and say, what's the pressure operating at this point? And it also gives you a nice feeling of what's the time history, because you can watch the needle bouncing around if there's pulsations in the flow. Now, if you need to acquire the signal either in a computer or a microprocessor or for some reason, you would typically then use a pressure transducer, which looks like this. And again, a port right here. I've got 4 electrical leads on this side. And what's going on here is we've got a metal diaphragm. The pressure acts on that diaphragm, creates a strain. I've got strain gauges on the diaphragm, and as those strain, it changes the resistance. We have a Wheatstone bridge inside of there. We amplify the millivolt signal into a voltage signal that we can send to the computer. So this allows us to convert a pressure into a voltage or a current that we can read in a computer or microprocessor. Now, for measuring flow, there's a number of different devices. One of the simplest is what we call a rotometer. And this is an example of a rotometer, and you can see this little slug that is sliding back and forth. So this tube-shaped area in here is conical, so it's smaller diameter at the bottom, larger on the top. I've got flow coming in here, coming out up here. So I've got gravitational force acting downward and the viscous force of the fluid acting upward. When those balance, the slug stays in one location, and I can measure the pressure off the top of that slug. Other ways to measure volumetric flow rate are gear flow meters, Coriolis flow meters. There's a whole lot of other types, like the turbine flow meter that's shown here on the slide. Many other ways of measuring flow rate. And then there's also some that will measure mass directly. So a variety of ways, just a sampling that you'll see right here. We'll talk about more when we get to the lab. So some power calculations. Now, I was mentioning that I recommend doing your calculations in the SI system. Let me illustrate that now. Power in hydraulics is simply the pressure drop times the flow rate. So maybe I've got a hydraulic power going into my actuator. I've got to know what the pressure drop is, so I need a reference pressure. Perhaps it's atmospheric pressure. And so I've got a pressure and a flow rate going into here, so I can calculate the hydraulic power entering that device. And let me throw some numbers in here just so that we can provide this example. So in the SI system, let me give you a pressure where our delta P might be 21 megapascals. And our flow rate, let's use a value of just, let me get my numbers here, of 12 liters per minute. Now remember that I said the base unit in the SI system for flow rate is cubic meters per second. So I'm going to convert this into cubic meters per second. And this flow rate ends up being 2.04 times 10 to the minus 4th cubic meters per second. So now when I do my power calculation, this is just equal to the pressure drop times the flow rate. So my pressure is 21 times 10 to the 6th pascals, which is a Newton per meter squared. Multiply this by my flow rate, which is 2.04 times 10 to the minus 4th cubic meters per second. I multiply these together and I end up with just over 4 kilowatts, 4,284 watts. And one thing I always recommend doing whenever you get done with one of these calculations is verifying that your units worked out. And so we can say, what is a watt in this case? A watt is just equal to a Newton meter per second. And we see that we do have newtons in the numerator. I've got meters cubed divided by meters squared, so I've also got meters in the numerator and seconds in the denominator. So my units do work out. Now let's try to do this in the US system. So first of all, I need to say that my horsepower is the unit of power, and this is 550 foot-pounds per second. A little bit odd number, but again, created when horses were doing the majority of the work. And now my power calculation, let me first of all give my pressure drop in the standard units of PSI. So 21 megapascals is approximately 3,000 PSI. And my flow rate of 12 liters per minute ends up being about 3.2 gallons per minute. So now when I multiply all this together to get my power, My power is my pressure of 3,000 psi, pounds per square inch, times my flow rate of, 3.2 gallons per minute. And now I've got to do a bunch of unit conversions to get me to the units that I want to be in. So I've already got pounds, which is what I need for foot-pounds per second. But I'm in minutes, and I'm in gallons, and I'm in inches squared. So I need to do a few unit conversions. So first of all, let's say that 1 foot is equal to 12 inches. And then I can say that gallons to cubic inches is 231 inches cubed per gallon. Then I need to convert time, and I can say 1 minute is equal to 60 seconds. And finally, I can convert my power into a unit of horsepower. So I can say that 1 horsepower is 550 foot-pounds per second. And finally, I can crunch through this and say this is 5.7 horsepower. So notice all the extra steps to do all these unit conversions when we're doing this in the US system. This is why I recommend doing your work in the SI system. It'll make your life a lot easier in the long run. So in summary with this video, what we've talked about is, first of all, pressure, the measurement of pressure, the measurement of flow rate as through and across variables. We then talked a little bit about how to measure them with these various devices of pressure transducers, rotometers, and then talked about how to do pressure calculations as just the pressure times the flow rate. I'm sorry, power calculations as pressure times the flow rate. Thank you.